So today we will we'll continue to discuss our vectors. We already discussed part of it yesterday, but today I will review to you what we have learned yesterday, and then once we are done with that, we will continue to another section. Okay? So let me review yesterday. This is what we have learned yesterday. This is vectors. Number one, we know that vectors have quantity that has magnitude and also we have directions. That's what we call vector. If we have only magnitude, we call it scalar. We have directions, so the vector need to have two components, magnitude and direction. You must have one magnitude. We also have what we call by zero vector. This zero vector has magnitude. Magnitude, I make it short. Let's say this is, I make it short. Call it magnitude of 0, and directions anyway. Because it's a point, it's a dot, it's just a dot like this. So the magnitude has no magnitude. There is magnitude, but the magnitude is 0. So the direction could be anywhere. That's what we call zero vectors. And number 2, we already also discussed yesterday that this is what we call the A plus B and also A minus B. Okay, two vectors. This we call addition of vector. This is subtraction of vectors. Okay, so here let's say I have this is A and this is vector B. So if I add up A plus B, so what I have is, you can use here A, and then B is going this way, and this guy we call by the result of this vector will be A plus equal. So remember last time what rules we used to find this A plus B? This is hat, this is tail, so this is hat plus tail. A hat to tail. Okay? Another way to solve this problem is by taking this is hat to tail, hat to tail. Hat you can also say tip if you want. Tip or hat, say hat to tail or tip to tail. Another one, you can also take this one as A, and then you take B, you test it here. This is B, and then what we have is using this, and then you will have. Either you choose this process or this process, the result is the same. Okay? And so this is what we call tail to tail. And people also call this one parallelogram. We call it parallelogram. Yes. That's the same. Okay. Okay. And then we also say, let's say now we want to find A minus B. How about this? A minus B. We have H going this way, we we have b going that way. And so this one is the same as, remember, plus minus. Cool? A plus minus b. Okay? We know A is going that way. And we know B is heading downward. And so minus B must get in opposite direction. Okay? So this B is going that way. Minus B. Is that okay to you? So we end up this guy. And so the result will be either you use head to tail or tail to tail. It's up to you. Doesn't matter. So we have here our A, and then minus B is going that way. And so the result will go from here to here. And this is A minus B. So it's clear A plus B is not the same as A minus B. Okay? Alright. You can try by yourself how to get these parallelogram rules. This is head to tail, and then you can use tail to tail. If you use tail to tail, of course, you'll have like so. This is A, and this is minus B. And then you will have something like this. This is A minus. Cool? Everyone's clear about this? Alright. Question? We already discussed this yesterday. Any questions? No question? Come on. There's no such thing as stupid question. Question is question. You don't understand, you ask question. You don't want to ask in the class, of course you can ask online, WeChat or email. Feel free. Or after the class. Okay? Any question? No question. Unbelievable. Okay. Let's go now for this what we call distance. And positions. And what we call distance. Anyone has an idea what it means by distance? Who can say something about distance? What is distance? Can you? What's your name, please? Stephen. Stephen. Okay. So there are two Stephen here?
No, only one Stephen.
Isn't you also Stephen?
Peter.
Peter. Oh yes, sorry. Stephen. Do you have any ideas, friends, about distance? What you can say is something about distance.
1, 9, 1, 2, 3.
Okay, that's distance.
1,
Okay, do you think distance has direction? Distance has direction? Anyone can say distance has direction or not? When you say the distance from our city to another city, do you need any direction? No, you don't need any direction. All you need to do is to say the value, the magnitude from here to there. That's all. There is no distance. There is no direction. It's only magnitude. So distance is a scalar. Distance is a scalar. It's not a vector. Not at all. I'll give you an illustration what you mean by distance. let's say this is x and this is y. This is space. You know, x is that way and y is that way. No. X is that way and y is that way. Okay, in space. In flat. Okay, it's flat surface. It's x and y. Okay, and then go here. And then you move around. Nice. What is your distance? Your distance is the length of this pair, yes? And from here, going here, and then here, and so on going here again. That's what we call distance. Yes, there is no magnitude. That's what we call distance. If I go from here, then go there. So my distance is from there going to here. Let's say from there going to here, going to there is 3 meters, and from there going to here, let's say 4 meters, so 3 plus 4, so 7 meters in total. And if I get back here, 3 plus 4 and plus 4. Okay? 7 plus 4. So 11. That's what we call the distance. It has nothing to do with the direction. No direction at all. It's all about magnitude. That's what we call distance. Okay? We need to be clear about distance and displacement very soon. So distance basically what we call is total length. The total length here, the total length of the path of an object. Let's say you move from here going to here, so the total length from here and going to here again